Welcome to the lecture on Fourier series and harmonic analysis. We know that the vibration motions can be periodic, harmonic and random. Similarly, the vibration forces, the excitation forces can be periodic, harmonic or random. So, we know that a periodic motion is a motion that repeats itself after an equal interval of time. Moreover, harmonic motion also repeats itself after an equal interval of time, but the additional condition is that the acceleration is proportional to displacement and the direction is always towards the mean position. So, today we will discuss whether there is any relation between periodic motion and harmonic motion. Means, can we express a periodic function in terms of harmonic functions? So, therefore, the lecture contains we will discuss. So, what is Fourier series? So, Fourier series we will discuss. Fourier series expresses a periodic function in terms of a harmonic function, and the branch of mathematics that deals with splitting a periodic function into a series of harmonic function is called harmonic analysis. So, here we can see there are periodic functions. They are not harmonic functions, but according to the Fourier series, we can express these functions in terms of harmonic functions. Harmonic functions means sine functions and cosine functions. So, here the Fourier series says that if we have a periodic function f t, we can express this periodic function f t as equal to a0 by 2 plus sigma n equal to 1 to infinite a n cos n omega t plus b n sin n omega t, where omega is the frequency of the periodic function. And we can see the basic harmonic functions. They are sine, it starts with 0, maximum at pi by 2, and then again 0 at pi, then negative minus at 3 pi by 2 minus and then again 0 at 2 pi. So, this completes one cycle of sine function, and similarly cosine function is maximum at 0, then minimum at pi by 2, then negative maximum at pi, and then again 0 at 3 pi by 2, and then again it will be maximum at 2 pi. So, it will complete one cycle. So, we can express this f t into harmonic function. So, f t is a periodic function that we can write a0 by 2 plus sigma n equal to 1 to infinite a n cos n omega t plus b n sin n omega t. So, if we know, because we know omega, so omega is 2 pi by tau, where this is equal to, this is natural frequency or we can call it as frequency of the periodic function, and tau is time period of the periodic function. So if we can know we can evaluate A0, AN and BN, because A0, AN and BN, they are the constants that we must know. Then we can express our periodic function ft into harmonic function. Now here we can see that this harmonic function vary n equal to 1 to infinite. So we can have infinite terms and they will assemble to make this periodic function. In order to get A0, AN and BN, let us say this is equation number 1, we have to find. So what we do, we integrate both sides of this equation with respect to t for one cycle. So integrate ft dt for a cycle, so any instant of time t, so 2t plus 2 pi by omega. So one cycle, this is time period, 2 pi by omega is time period, and we integrate. So a0 by 2 dt t to t plus 2 pi by omega, and then plus here we integrate t plus 2 pi by omega sigma n equal to 1 to infinite a n cos n omega t plus b n sin n omega t dt. So here we can write a0 by 2 dt, because a0 by 2 is constant, we can write t plus 2 pi by omega plus sigma n equal to 1 to infinite a n cos n omega t dt plus bn sin n omega t dt and sigma n equal to 1 to infinite, and then integrate t plus 2 pi by omega. So in order to solve these integrals, we will use some formula of integration. So from here we can write this a0 by 2, and we can write here it is t plus 2 pi by omega minus t plus. Now these terms, so we have integral for one cycle t to t plus 2 pi by omega, and we have an is constant, and for n equal to 1 it is a1, for n equal to 2 it is a2, and cos n omega t dt. Now according to expression here, we can see according to this expression t plus 2 pi by omega cos n omega t dt equal to 0 for all n. So it means the integration, this integration an cos n omega t dt equal to 0 for any n value. So this will be equal to 0. Similarly, we can see that sin n omega t dt equal to 0 integral t to t plus 2 pi by omega is 0 for all n values. So here this also the summation will be 0 of integral. So we will have only a0 by 2 into 2 pi by omega. Now we can cancel out 2 and 2. So we can write a0 equal to omega by pi integral t plus 2 pi by omega ft dt. So our equation 2 gives us the value of a0, that is a0 equal to omega by pi integral t to t plus 2 pi by omega ft dt. So it means that if this is periodic, ft is the periodic function and we integrate it from t to t plus 2 pi by omega or any cycle, one cycle, we will find the value of a0. Now we have to find the value of an. So in order to get the value of an, let's first multiply this equation both sides with cos n omega t, and then we do the integration for one cycle. So let's first multiply. So multiply equation 1 by cos n omega t and integrate for a cycle. So here ft cos n omega t and here it will be a0 by 2 cos n omega t, then plus sigma n equal to 1 to infinite an cos n omega t square plus bn sin n omega t into cos n omega t. So this is we multiplied with cos n omega t. Now we have to integrate for one cycle. So we integrate, so ft cos n omega t dt, because we integrate t to t plus 2 pi by omega equal to a0 by 2 cos n omega t dt, and this is t to t plus 2 pi by omega plus, so again we integrate t to t plus 2 pi by omega an cos square n omega t, and here will come the summation n equal to 1 to infinite dt plus integrate t to t plus 2 pi by omega sigma n equal to 1 to infinite an sin n omega t cos n omega t dt. So this is our resulting equation. Now again we will apply the formula that we can see in the slide. So a0 by 2 cos n omega t, a0 by 2 is constant. So we have integral cos n omega t dt, we have integral cos n omega t dt, and for one cycle we can see it is 0 for all n. So here we can have 0. Now we come to another integral, that is cos square n omega t dt. So we see that for cos square n omega t dt, the first expression says that cos n omega t cos n into cos m omega t dt for one cycle, that is t to t plus 2 pi by omega, equal to 0 for m not equal to n and pi by omega for m equal to n. So when our n will go for a limit 1 to n equal to 1 to infinite, for all the terms this integral will be 0 except for n, because n equal to n. So, we will have this integral pi by omega into an. So, we have the integral is pi by omega and the constant an remains. Again here the third term, that is sin n omega t into cos n omega t, and we can see the third formula. It says that the sin n omega t and cos m omega t dt equal to 0 for one cycle for all m and n. So, this term will be 0. From here we can find an equal to omega by pi integral t to t plus 2 pi by omega ft into cos n omega t dt. So, this is our equation number 3, that gives us the an value of an. So, we know the periodic function, we multiply it with cos n omega t, then we integrate for one cycle and multiply with omega by pi, we will get an. Now, our objective is to get the last value bn. So, that is the coefficient of sin n omega t. So, in order to get bn, we will follow the similar process that we did for cos to find an. So, we will multiply this time with sin n omega t. The equation 1 will be multiplied by sin n omega t and it will be integrated for one cycle. So, let us do. So, multiply equation 1 by sin n omega t and integrate for one cycle. So, if we multiply 1, we will get ft sin n omega t equal to a0 by 2 into sin n omega t plus sigma n equal to 1 to infinite a n cos n omega t into sin n omega t plus sigma n equal to 1 to infinite bn sin n omega t into sin n omega t or sin n omega t square, whatever. Now, again we will integrate this equation from t to t plus 2 pi by omega, that is for one cycle. So, we integrate so ft sin n omega t dt t to t plus 2 pi by omega equal to again a0 by 2 sin n omega t dt t to t plus 2 pi by omega plus t plus 2 pi by omega limit, then sigma n equal to 1 to infinite a n cos n omega t into sin n omega t dt plus integral t to t plus 2 pi by omega sigma n equal to 1 to infinite bn sin n omega t. So here is square dt. Now we have written this expression with integrals. So we will use the formula that we can see here. So here the first term in the right hand side, so that is a0 by 2 sin n omega t dt. So we can see here that sin omega t dt is 0 for any n, so this term will be 0 plus the second term. So second term is cos n omega t into sin n omega t dt, and this for one cycle. So we can see here cos n omega t into sin n omega t sorry, is 0 for all m and n. So this second term will also be 0. Now we come to the third term. The third term we have sin square n omega t. So again the second relation in the slide we can see integral sin n omega t into sin omega t dt equal to 0 for m not equal to n. So for all the terms there will be only one term where m equal to n, rest all the terms in that infinite series, infinite summation 1 to infinite will be m not equal to 1, and that will be 0. So only one term, that is m equal to 1, will be there, and so its value is pi by omega. So here we have bn, the constant, into pi by omega, the integral value. Now we can write here from here bn equal to omega by pi integral t to t plus 2 pi by omega ft sin n omega t dt. So this is equation number 4. So we have this, the equation 1 tells about the Fourier series, and then equation 2, 3 and 4 gives the value of coefficient of this Fourier series. Now we will take one example, and I will tell you how to apply this these formula to calculate the coefficients of the Fourier series. So let's take one example. So let's take one triangular shape periodic function. So in this triangular shape periodic function we see that this is 0 and 0 to 0.1. From 0.1 there is repetition of the cycle, then 0.2 it repeats. It means we have the time period of 0.1. So we have tau tau is 0.1. So let's say this is second. So 0.1. So we can find omega, and omega is 2 pi by tau. So that is 2 pi by 0.1. So it is 20 pi. So this is omega, the frequency of the periodic function. Here omega is circular frequency, that is in radian, and now we have to write this ft, the function ft. We have to write the function because we need to know how this function varies in one cycle. So let's write this function. So ft, so let's consider the cycle 0 to 0.1. In this cycle we have to express this function. So ft, so we see that ft is growing from 0 to 0.1 as linearly. So it is an equation of line. An equation of line that is passing through origin can be written as like y equal to mx. So this is general equation of line when we have the x and y coordinates. Now here our y coordinate is ft, so we write here ft, and x is t, so we write here t. Now m, what is m? So m is the slope of the line. So to find the slope m, we write m equal to, we take points, this point and this point, and we write this is y2 minus y1 upon x2 minus x1. So y2 here means the value of ft here. So value of ft here is 10 and value of ft here is 0 upon, so value of x2 minus x1, so that is time. So t is 0.1 minus 0. So we have 10 by 0.1 equal to 100. So we can write here ft equal to 100t. So here ft equal to 100t. Now we say it is 0 less or equal to t less or equal to 0.1. So the complete cycle it is defined as ft equal to 100t. So we got ft. Now our objective is to find a0, an and bn. So we will put this value of ft in this formula and we will compute. So let's do it. So let's calculate a0. So a0 equal to omega by pi. Omega we calculated, it is 20 pi by pi, and cycle we start from 0 to 0.1. So the t we start t equal to 0. So it is 0 to 0.1. Okay. And then ft dt. So ft is 100t and dt. Now we solve this integral 20. So into 100 we take out, and t dt 0.0 to 0.1 t dt. So we have 2000 into, so t integral is t square by 2, and we have limit 0 to 0.1. So integral t power n is equal to t power n plus 1 by n plus 1. So we have 2000 by 2, we take 2 out, and then 0.1 square minus 0 square. So we have 1000 into 0.01, 0.1 square. So this is 10. So we got a0 equal to 10. So the first coefficient we got. Now we need to know an. So an equal to omega by pi ft cos n omega t dt. So it is 0 to 0.1, again we will take. So it is 20 pi by pi 0 to 0.1 100 t into cos. So omega is 20 pi, so it is 20 pi n t into dt. So here we can write 2000 because pi is cancel out and this come 2000. 0 to 0.1 t into cos 20 pi n t dt. Now here there are two functions of t. So we have to first do the integral by parts and then we will apply the limits. So we have 2000 so integral by parts. So let's take, this is first function and this is second function. So we have the formula that we apply. So the formula is that we write like first function into integral of second function. So it is cos 20 pi n t dt 0 cos 20 pi n t dt minus integral of, so differential of first function. So differential of t is 1 because t by dt is 1, and then integral of the second function. So this is cos 20 pi n t dt, and then we will put the limit 0 to 0.1 on this. So we can solve it. 2000, we have t into, so this we have cos will go to sine 20 pi n t by 20 pi n minus, so again this integral, so cos this is sine 20 pi n t upon 20 pi n dt, and this is 0 to 0.1. So we will solve 2000 t into sine 20 pi n t upon 20 pi n minus, so sine integral is minus cosine, so minus minus plus, and this is cos 20 pi n t by, so 20 pi n again will be multiplied here, so 20 pi n square, and this limit will go 0 to 0.1. Okay, so we can write here an equal to, so we give the limits to this, so it is 2000 t into sine 20 pi n t by 20 pi n, limit 0 to 0.1 plus cos 20 pi n t by 20 pi n square, this again limit 0 to 0.1. So here 0.1 we put 0.1 into, this is sine 2 pi n, because t equal to 0.1, so it is 2 pi n, of course n minus, because this is 0, so t equal to 0 upon 20 pi n plus this is 0.1, so it is cos 2 pi n minus, again it is 0, so cos 0 is 1, so upon 20 pi n square equal to 2000. Now sin 2 pi n is 0, because for any n equal to integer value n equal to 1 to infinite, we will have always 2 pi, 4 pi, 6 pi, so these are always 0. So this is 0, so 0, it is 0 plus here cos 2 pi n is always 1, and so 1 minus 1 for any n, for example n equal to 1, it is cos 2 pi, so cos 2 pi is 1, cos 4 pi is 1, so 1 minus 1 is again 0, so we get that an is 0. So we find that this the value of the an is 0. Now we calculate bn, so bn we will calculate similarly, so it is omega by pi 0 to 0.1 ft sin n omega t dt. So we can put here 20 pi by pi 0 to 0.1 100 t into sin n omega t dt, and we can solve this integral in the similar way, and we find the value of this integral is minus 10 by n pi. So we go for solution similarly to an, and we will find this as b. So what is our Fourier series? So for this periodic function, so ft equal to a0 by 2 plus, so we know we can see this equation 1 and we can put these values. So ft equal to a0 is 10, so 10 by 2 equal to 5 plus sigma n equal to 1 to infinite. Now an is 0, so there will be no cosine term, only bn and sin omega t. So bn is minus 10 upon n pi into, so we can write here, sorry, so here we can write ft equal to 5 plus bn is minus 10 by n pi, and here is sigma n equal to 1 to infinite, and here sin n omega t. Now we can write like 5 minus 10 upon pi sin n omega t by n, and sigma n equal to 1 to infinite. Because n is 1 to infinite, we keep all the n terms here, so we can express this 5 minus 10 by pi and sin omega t plus sin 2 omega t by 2 plus sin 3 omega t by 3 plus and so on. So this is my Fourier series that contains n terms. So we have another thing is that there are even and odd functions. So a even function is that if we put x minus t equal to a, if we put minus t in spite of t, it is xt. So this is even function, and for even function we have only cosines, no sine terms. But if we have odd functions, means if we put x minus t equal to minus xt, it is minus xt. So Fourier series contains only sine terms. So for example, this function, the rectangular wave that we the triangular wave that we discuss, this function ft equal to 100t, we put f minus t so if we put f minus t equal to 100 minus t So, equal to minus 100t equal to minus ft. So, it is an odd function, and that is why we see that the cosine coefficients are 0. So, therefore, we have only sine. Now, for this triangular series we can see that the series is infinite because it go from n equal to 1 to infinite, but first few terms can give us a feeling that the harmonics are going to produce the periodic function. So, we can see here one term approximation, that is purely the constant term a by 2, that is here 10 by 2, so 5, and then the second term 2 term approximation, it is some sign terms, that is in negative because there is a negative sign, and so the first sign term, then 2 terms, 3 terms, and they are going to result the actual periodic signal. Thank you for your attention, and see you in the next lecture.